Hi everyone, I am Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the eigenvalue problems and characteristic equations. If A is a square matrix of order n, we can form the matrix A minus lambda I, where lambda is a scalar and I is the unit matrix of order n. Then modulus of A minus lambda I equal to 0 is called the characteristic equation. The determinant A minus modulus of A minus lambda I when expanded will give the polynomial which is called as a characteristic polynomial of matrix A. Note, for any square matrix A, the sum of the eigenvalues of a matrix is equal to trace of the matrix. So for 2 cross 2 matrix, the characteristic equation is lambda on lambda square C1 minus C1 lambda plus C2 equal to 0, where C1 is the sum of the main diagonal elements and C2 is determinant of A. And for the 3 cross 3 matrix, the characteristic equation is lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0, where C1 is the sum of the main diagonal elements and C2 is the sum of the minus of the main diagonal elements and C3 is determinant of A. So this is the formula we want to proceed to calculate the characteristic equation. So shall we discuss about the some problems based on this. The first one is find the characteristic equation of 1, 2, 0, 2. So let this matrix as A and then write the characteristic equation general term. So lambda square minus C1 lambda plus C2 equal to 0, where C1 is the formula for C1 is sum of the diagonal elements. Here one diagonal are 1 and 2. So adding these two, you got the answer as 3. And then C2. C2 is determinant of A. So determinant of A means the writing the determinant and first cross minus next cross. So multiplying these two value and we get the answer as 2. So we can write C1 C2 value in the general term. So at last I got a lambda square minus 3 lambda plus 2 equal to 0 is the characteristic equation for this sum. Next we move on to the second sum. Find the characteristic equation of 2 minus 3 1 3 1 3 minus 5 2 minus 4. So for the solution part, first fix the matrix, give some name A. So next to write the general term. So it is a 3 by 3 matrix. So we get the cubic equation. So we write the cubic equation lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0, where C1 is the diagonal elements. So and then 2 plus 1 minus 4 equal to, conclusion of this term is minus 1. Next is C2. C2 is nothing but the first diagonal value you want to choose. That is the 2 you want to choose. Omit this row and column. The remaining 4 values you want to write. So choose the remaining 4 values. Plus next diagonal value 1. So this one, choose the 1 and omit this row and column. So then 4 corner values you want to choose. So we wrote all the 4 values, first cross minus next cross, we got the answer here. We write here. Next third eigenvalue. So third diagonal value is minus 4. So omit this row and column and we get these 4 values. So from these 4 values, here the conclusion, first cross minus next cross, we got the conclusion, and then from these 3 values we got the result as C2 equal to minus 2. So this is another thing. Next go for the next C3 value. So C3 is nothing, it is we already studied in our school itself. So determinant of A. So first row alone we want to consider 2 into the remaining row and column omitted, remaining 4 values. So 1 minus 4, 2 first cross minus second cross, the value you have to write. And then for next minus, the formula minus, you just write formula minus and then here already one minus value have been right there. And then first the omit this row and column, remaining 4 values you want to write it here. So first cross minus second cross, the answer here, plus, and then last value 1. So that 1 here means you want to omit these values and you want to write these alone. So first cross minus next cross, you got the answer as 6 plus 5. So a conclusion of this term is equal to 0. So the constant term becomes 0. Therefore the characteristic equation is lambda cube plus lambda square minus 2 lambda equal to 0. Thank you.